Hello all, this is SANDEEP Kumar and I welcome you back to my YouTube channel Concepts of IIT Maths, and we are in the chapter of sequence and series. In the previous video we have learned the concept of sum of n terms of an AP, how to derive the sum of n terms formula, and then how and few more things about sum of n terms had been discussed in previous video. And in today's video we'll discuss about some important model problems on sum of n terms on AP. Okay, so when it comes to the subtopics, first this is something that I missed in yesterday's video. It is how to write Tn, the nth term from sum of n terms in just 2 steps. Okay, and next we'll look into the model problems on sum of n terms of AP. Now let us continue. Let us see how to find the nth term an or tn from sum of n terms. So this proof is done already in yesterday's video, where if sum of n terms is of the form an square plus bn, then we can say that the sequence formed using the sum of n terms is in AP, that we have discussed in yesterday's video already. Okay, and also using the formula Tn is equal to Sn minus 1, we have derived that the nth term is given by a into 2n minus 1 plus b. This is something that we have derived in previous video already. So therefore, dear students, if you look at Sn is of the form an square plus bn, where a and b are some constants, they can be real numbers. By looking at Sn, we can write Tn directly. How do we write it? Take the same coefficient a. Okay, take the same coefficient a and replace n square with 2n minus 1. And here bn becomes a b. Okay, so I'm repeating. So a will be a itself, and n square is replaced with 2n minus 1, and bn becomes a b. So this gives you the nth term. For example, if Sn is equal to minus 3n square plus 4n, if Sn is equal to minus 3n square plus 4n, then the sequence formed will be in AP, and its nth term is given by, keep minus 3 as it is and replace n square with 2n minus 1 plus 4n will be written as 4. Now if you expand it, we will get a minus 6n plus 3 plus 4, which is plus 7. So for an AP, if sum of n terms is minus 3n square plus 4n, then its nth term is minus 6n plus 7. And moreover, we also know directly that the common difference can be written directly by looking at the coefficient of n. What is the coefficient of n in the nth term? It is minus 6, therefore the common difference is minus 6. Or we can also write the common difference by looking at Sn, correct? We learned in yesterday's video. So what is it? The common difference will be 2 times coefficient of n square. What is it? 2 times coefficient of n square from Sn. 2 times coefficient of n square means 2 into minus 3, which is minus 6. This will be useful in problems. By looking at Sn directly, we can write a common difference. Or by looking at nth term also, we can write directly common difference. So keep this in mind. So if Sn is an square plus bn, then we can write nth term directly as a into n square is replaced with 2n minus 1 and bn is replaced with b. Okay. Now let us look at 3 important models on sum of n terms. Well, first model, in an AP, if sum of first m terms is equal to sum of first n terms, so Sm is equal to Sn, then we can directly say that the sum of first m plus n terms is equal to 0. Let us see the proof of it. Let me prove it step by step. So it is given that sum of m terms is equal to sum of n terms in an AP. So using sum of n terms formula, the Sm in an AP is m by 2 into 2a plus m minus 1 into d equal to, and sum of n terms is n by 2 into 2a plus n minus 1 into d. On both sides, by 2 and by 2 will get cancelled. Let me expand this term. So what do we get? M into 2a, which means 2am, plus m into m minus 1, m into m minus 1 into d equal to n into 2a, so 2an, plus n into n minus 1 into d. And I will take everything, all these two terms to the left side. I will transpose it. So what do we get? 2am, and if plus 2an comes this side, minus 2an, and then plus m into m minus 1 into d, and if plus of this term comes left side, minus n into n minus 1 into d equal to 0. So in the first two terms I can take 2a common, 2a into m minus n, and in the next two terms I can take common difference, d common. So we get m into m minus 1 minus n into n minus 1, right side equal to 0. So keep the first term as it is, 2a into m minus n. Let me expand this, m square minus m, and then minus n square plus n into d equal to 0. So please observe, if I write 2a into m minus n plus, here m square minus n square can be written as using a square minus b square identity. What do you get? M square minus n square is m plus n into m minus n. And then in the remaining two terms, if I take minus 1 common, minus 1 if I take common, plus m and minus m. Okay, the entire thing is multiplied with d equal to 0. So let's continue. While solving these problems, just take down the notes if needed. Now please observe that in the first term, second term and third term, we can take m minus n common. So when I take m minus n common, in the first term we have only 2a plus, in the second term we have only m plus n, we have only m plus n because I took m minus n common, and in the third term we have minus 1, close the bracket, into d here equal to 0. And remember that if m is not equal to n, I can take into m minus n to the right side, right? So then I'll get, if m minus n gets to the right side, becomes 0 by m minus n, which is 0. So 2a plus m plus n minus 1 into d equal to 0. If I call it as equation number 1, we are supposed to prove that sum of m plus n terms is equal to 0, right? Now sum of m plus n terms using Sn formula is m plus n by 2 into 2a plus m plus n minus 1 into d. Sn is n by 2 into 2a plus n minus 1 into d. So sum of m plus n terms will be m plus n by 2 into 2a plus m plus n minus 1 into d. Just in the previous step we proved that 2a plus m minus 1 into d is 0. So this entire thing is 0. So 0 into anything is 0. Over, therefore sum of m plus n terms is equal to 0. Sum of m plus n terms is equal to 0. Therefore dear students, remember, if in an AP, this works only for AP. If sum of m terms is equal to sum of n terms, then sum of m plus n terms will be equal to 0. Let us see its basic application. You can create your own question on this model, right? Here is a simple question based on that model. In an AP, if sum of 7 terms is equal to sum of 8 terms, sum of the first 7 terms is equal to sum of first 8 terms, then what is the sum of first 15 terms? Over. So what is the answer? So if sum of 7 terms plus sum of 7 terms is equal to sum of 8 terms, then we know that sum of 7 plus 8 terms is equal to 0. That is, sum of first 15 terms is equal to 0. A simple answer. If you know that model, in exam you don't have to solve everything. You can directly say that the answer is 0. So we will go for the second model. So the second model, in an AP, if the ratio of sum of m terms and sum of n terms is given by am square plus bm by an square plus bn, then the ratio of the mth term and nth term is a into 2m minus 1 plus b by a into 2n minus 1 plus b. Remember, in one particular AP, they have taken sum of m terms and sum of n terms in one particular AP. Okay, now let us see how to prove it. Generally, one small mistake that children regularly do is when we ask what is sum of m terms from the ratio, the mistake that they make, they say that sum of m terms is equal to am square plus bm. That's it. They'll say it blindly. But in ratio, we are not supposed to take the like that. So what to write here? The sum of m terms is equal to am square plus bm multiplied with some constant k. Of course, k should not be 0. Okay, na? And sum of n terms is equal to what? Same an square plus bn into k. The same constant k. Okay. So just before we have told that sum of m terms in an AP, if it is like this, then I can write its nth term directly. Sorry, mth term. What is the mth term? By looking at this, the shortcut a as it is, and m square is replaced with 2m minus 1, and bm is replaced with b. Of course, k is as it is into k. Similarly, if sum of n terms is this, then the nth term is given by a as it is, and n square is replaced with 2n minus 1 plus bn is replaced with b. The entire thing is multiplied with k. Now you can take the ratio. Therefore, the mth term divided by nth term is equal to this divided by this. So when I divide this with this, k and k will get cancelled. We'll get a into 2m minus 1 plus b divided by a into 2n minus 1 plus b. Got it? So this is the ratio of mth term and nth term. Let us see an example. Here is a question in an AP. If a1 plus a2 plus a3 and so on up to am divided by a1 plus a2 plus a3 and so on up to an is equal to m square by n square, then what is the ratio of its fifth term and 18th term? That is the question. Well, we know that the numerator is the sum of the first m terms in an AP, Sm, and the denominator is sum of first n terms in an AP, a1 plus a2 plus a3 and so on up to an. So it is sum of first n terms in an AP. So Sm divided by Sn is equal to m square by n square. In that case, using this, we can say that Tm divided by Tn is equal to what? First of all, m square coefficient is a and the constant here is 0. So I can write it as 1 into m square plus 0 divided by 1 into n square plus 0. So using the shortcut that I have discussed before, we can say that 1 as it is, m square is replaced with 2m minus 1 plus 0 divided by 1 as it is, and n square is replaced with 2n minus 1 plus 0. So therefore, what is it, dear students? The ratio of mth term to nth term is 2m minus 1 divided by 2n minus 1. The ratio of mth term to nth term. Then what is the ratio of fifth term to 8th term? 18th term. So Tm or Am, both are same only. Please understand this. Okay, na? So Tm is nothing but Am and Tn is nothing but An, equal to 2m minus 1 by 2n minus 1, and they are asking A5 divided by A18. So what is it? M value is 5 and n value is 18. Just substitute. 2 times m value is 5 minus 1 divided by 2 times 18 minus 1. So what do we get here? We get 9 divided by 35. The answer, the required answer is what? 9 divided by 35. The answer is 9 by 35. We'll go for the third model now. And before going to third model, one small thing, if you observe the question, just think once. They have added the terms in AP and the numerator looks like m square. And they added the terms in AP and the denominator looks like n square. What can be the AP? Can you guess it? What can be the AP? The AP is very simple. AP is multiples of consecutive odd numbers. Do you remember this? Do you remember that 1 plus 3 plus 5 and so on, m terms? If I take m terms, the answer will be m square, and if I take n terms, the answer is n square. I'm sorry, that is not visible. Let me write it here below. What is it? 1 plus 3 plus 5 and so on, n terms if I take, the answer is n square. Correct? The answer is n square. So here also they have added AP and the numerator is m square and the denominator is n square. What does it means? Certainly A1, A2, A3, they are not directly odd numbers, but they are the multiples of odd numbers. Okay, now what is the reason means? The numerator is m square into some constant now. M square into some constant, which means it is k, 3k, 5k and so on, and so on, the mth term into k. Okay, fine. I hope you understood what I am trying to say. If you have not understood, it's not an issue. Let us continue with the next model. Here is our third model. If the ratio of sum of n terms of two different APs, that means sum of n terms in the first AP divided by sum of n terms in second AP. Okay na? So if sum of n terms in first AP divided by sum of n terms in second AP is given by an plus b by cn plus d, where a, b, c, d are some constants. They can be real numbers, they can even be complex numbers. But one thing is a and c are not equal to 0. If this is happening, then what is the direct formula to find the ratio of their nth terms? The ratio of their nth terms, Tn by Tn dash, is equal to same a as it is, and n is replaced with 2n minus 1 plus b, and c as it is, and n is replaced with 2n minus 1 plus d. Okay, now this is something that you can easily prove it. I'll just give you a few steps to prove it. So if I look at the proof, so first of all, I'll multiply with n in the numerator and also in the denominator. If I multiply with n in the numerator and denominator, I'll get an square plus bn and cn square plus dn. Okay, now follow the proof of the previous model. You can easily derive that Tn by Tn dash is equal to, what is it? A as it is, and n square is replaced with 2n minus 1 plus bn is replaced with b divided by c as it is, and n square is replaced with 2n minus 1 plus dn is replaced with d. You can follow the proof of the previous model. You got it. You can try it easily, just like that you will get the answer. Okay, so therefore we have proved that if Sn by Sn dash is equal to this, then Tn by Tn dash is equal to this. And moreover, dear students, you already know how to take the common difference. You already know how to take the common difference if Sn is given or Tn is given, right? So what is it? In that case, what is d by d dash? What is d by d dash? If I look at Sn, the common difference of Sn is 2 times the coefficient of n square, correct? So 2n square divided by, and here I'm sorry, wait a second, it is not 2n square. 2 times the coefficient of n square means 2a divided by, and 2 times the coefficient of n square here is 2c. Actually I should write 2a into k and 2c into k, but it's okay. So what is it? D by d dash is equal to, the common difference of numerator is 2 times n square coefficient divided by 2 times n square coefficient, which is nothing but a by c. So the ratio of common difference is a by c, and the ratio of nth terms is this. A small note point. What is it? What if a comma c both are equal to 0? Let us see. What is that note point? If the ratio of sum of n terms of two APs is given by Sn by Sn dash is equal to b by d, and Tn by t, then what happens? Then Tn by Tn dash will also be b by d only, and d by d dash is not defined. Okay, now it is not defined. What is the reason? Let us check it. Let us see how to prove it. If you want to prove it, let us convert the numerator as a quadratic polynomial without constant. How? Multiply the numerator and denominator with n square plus n. So b into n square plus n by d into n square plus n. I have converted the numerator and denominator as what? Quadratic polynomials without a constant. So now this is bn square plus bn divided by dn square plus dn. Now we already know that if the ratio of sum of n terms looks like this, then the ratio of the ratio of nth terms is given by what? B as it is, and n square is replaced with 2n minus 1 and bn is replaced with b. Similarly, d as it is, n square is replaced with 2n minus 1 plus dn is replaced with d. Okay, so now numerator, if you observe, minus b plus b will get cancelled, you will get 2n into b, and minus dn plus d will get cancelled. When I expand, I will get 2n into d. So 2n also will get cancelled. Therefore, tn by tn dash is equal to b by d. Okay, now, so dear students, a small thing is, how do we find out that d by d dash is equal to 0? Let us see. Actually, Sn by Sn dash is equal to 0 into n plus b divided by 0 into n plus d. Correct? Or 0 into n square plus bn and 0 into n square plus dn actually. So the coefficient of n square is 0, the coefficient of n square here also it is 0. So d by d dash is equal to what? 2 times the coefficient of n square by 2 times the coefficient of n square. So which is 0 by 0, that is not defined. Okay, now the ratio of common differences is not defined. And a small observation is, we can use even this method to prove that tn by tn dash is equal to b by d. Even in this method, if you see, what do we get? Tn by tn dash is equal to 0 as it is, and n square is replaced with 2n minus 1 plus bn is replaced with b, and 0 as it is, n square is replaced with 2n minus 1 plus dn is replaced with d. Even now you will get b by d. In this method also we can prove that the ratio of nth terms is equal to b by d. Okay, and the ratio of common differences is not defined. Got it? Let us see an example based on this. And before going to example, let us see one more note point. Let us see what is this note. In the previous model we have seen, what we have seen there, they have given the ratio of sum of n terms, and using it we have found the ratio of nth terms. But in this note, they have given us the ratio of nth terms, and we are supposed to find the ratio of sum of n terms. So what is it? If the ratio of nth terms is an plus b by cn plus d, then the ratio of sum of n terms is a into n plus 1 by 2 plus b by c into n plus 1 by 2 plus d. Very simple thing is, here n is replaced with n plus 1. Logically, I'll tell you how it is proved. Very simple, dear students. When the ratio of Sn and Sn dash is given, okay, now as an plus b by cn plus d, we have proved that tn by tn dash is equal to what? A into 2n minus 1 plus b by c into 2n minus 1 plus d. Correct? Where n is replaced with 2n minus 1. Correct? Where n is replaced with 2n minus 1. Now in the reverse process, what happens? Let us see. Simple. In the reverse process, what we are doing? This is Sn to Tn. Okay, now in the reverse process, if I transpose plus 1 this side, n plus 1, and here 2n will be remaining, and into 2 comes this side by 2, and only n will be remaining. So what is it? In that case, from Sn to Tn, if n is replaced with 2n minus 1, then from Tn to Sn, then Tn to Sn, n will be replaced with n plus 1 by 2. From Tn to Sn, n will be replaced with n plus 1 by 2. This is just a logical explanation, not the actual explanation or actual proof. Okay, just logical. Got it? So fine. So therefore, if Tn by Tn dash is equal to an plus b by cn plus d, then this is Sn by Sn dash. Let us see an example and wind up today's topic. Just one example. Here is a question. In an AP, if the ratio of sum of, if in two APs, in two different APs, if Sn by Sn dash, that means sum of n terms in first AP divided by sum of n terms in second AP is equal to this 4n plus 1 by 2n minus 5. Then find the ratio of their 10th terms. What does it mean? The ratio of the 10th terms means they are asking us to find a10 divided by a10 dash and the ratio of their common difference, that means d by d dash. Just use the previous concept and find it out. What is it, man? I'll find an by an dash first. An by an dash or tn by tn dash, both are same meanings only. What is it? So I'm writing the shortcut 4 as it is and n is replaced with 2n minus 1 plus 1 as it is divided by 2 as it is and n is replaced with 2n minus 1 minus 5 as it is. Simply to say n is replaced with 2n minus 1 from here to here, that's it. Now if I expand it, I'll get 4 2s are 8n minus 4 plus 1 is minus 3 by 2 2s are 4n minus 2 minus 5 is minus 7. So therefore the ratio of their nth terms is 8n minus 3 by 4n minus 7. Using this you can find the ratio of any terms. They are asking us the ratio of their 10th terms, which means a10 by a10 dash is equal to, just take n as 10 here, take n as 10, 8 into 10 minus 3 by 4 into 10 minus 7. 80 minus 3 is 77 and 40 minus 7 is 33, so which is 7 by 3. The ratio of their 10th terms is 7 by 3. And what is d by d dash? D by d dash is nothing but the ratio of what? The coefficients of n. We have seen that Sn by Sn dash is equal to a divided by c, correct or not? So which means 4 divided by 2. What is the answer? D by d dash is equal to 2. Fine. D by d dash is equal to 2. So and the ratio of the 10 terms is equal to 7 by 3. So these are the three models that we have covered in today's video, dear students. So in the next video, we will look at more problems on sum of n terms and at the same time properties of arithmetic progression. Very, very important. Okay now. So I hope you have understood this concept very well. If you have understood this, do like the video, share it with your friends and comment if there are any doubts or if any mistakes. Okay. Thank you. Thanks for listening the video until the end. We'll see you in the next video. We'll continue and we'll meet back. We'll see you all in the next video. Thank you. Thank you one and all.